Hello students. Today we are discussing Michael addition reaction. Here we have acceptor and donor. So we should discuss about this. Here the donor means most active alpha hydrogen carbonyl group, and the acceptor means it is alpha beta unsaturated carbonyl group. For example, so this is alpha and beta. Alpha beta unsaturated carbonyl group. Carbon is most active hydrogen. When the base is abstract this hydrogen and get negative charge, it participates with the carbonyl group in the conjugation and get this negative charge again come back, and this pi bond is participating with the alpha beta unsaturated. Then the CC bond formation occurred. Here it is 1 2, it is 1 and 2 hydrogen, and this is R, whether it is R below or above, right? So this is Michael addition reaction. Generally it is a mechanism. So here we are observing only the alpha beta unsaturated, then it is Michael addition reaction. For example, in the Michael acceptor we are using, this is carbonyl group, and we can use also a nitro group or sulfonates or cyanides, amides and phosphonates or sulfoxide. Then this is Michael acceptor. Then we can create only the negative charge, and then this is the Michael addition reaction. So let's see example. We have, this is active, and here it is CH2 CO2 ET and taken to NaO ET and ETOH, and this is a base in the protic solvent. Then this abstract this hydrogen and get negative charge, and this negative charge is attacking on the alpha beta unsaturated like this. Then when this negative charge, and this is sodium, no, then sodium is balancing this one, and this negative charge when reverse conjugation, when this negative charge participating in the reverse conjugation, then ETOH is involved. Then this double bond attacking the hydrogen, this bond get negative charge on the oxygen, so this is a final product. Right. Similarly, here we have base, and this is alpha beta sulfonate, and this is it is a carbonyl group, and this is ester group. Ester group is activated of this carbonyl group. Then this carbon is the most active hydrogen, okay, and this is creating of alpha most active hydrogen, and we have discussed already in the part 1, okay. So this base can abstract this proton and get negative charge at this carbon, and participating in the conjugation Then okay, I'm writing like this. It is sodium CO18, right? And this is a enol. This is enol, and it is reacting with the sulfones, attacking on the alpha beta unsaturated. Next one, the second one is pH CH3 and heat. So this is toluene and this is reflex, means elimination. So here this H and SOPH, and these two are should be anti to each other. H sulfones should be anti to each other and get eliminated, and the final product is COET, C double bond O, and double bond is created. This is final product. Here this is CO2 amine, then this is the most active hydrogen. The LDA we are using, and it is chemically controlled and it is symmetrical. Then we have only one alpha hydrogen, then it can abstract this hydrogen only. Now here when we are using, this is alpha beta unsaturated carbonyl group, whether it is ester or it is a nitrile group. So here we are using two functional groups, then the rate will be slow because of steric hindrance only. Then this negative charge attack this alpha beta unsaturated. So this is the final product. And next one, and it is unsymmetrical ketone. This is alpha beta unsaturated ester group, and this is it is a potassium tetrabutanoxide in the tetrabutanol. Then it is kinetically it is thermodynamically controlled, then it attacks more hindered side only. Then the negative charge created at this carbon, and it is participating in the enolate, and after that this negative charge is attack on the alpha beta unsaturated. So this is the reduced activity, right? CO2 amine, and this is not a best leaving group, then it remains as such. And here we have CO2 tertiary butyl, and then it is LDA alpha beta unsaturated ester group we have. Then it is a Michael addition reaction. If the LDA attacks this hydrogen and get negative charge, right? And what happened, whether it is cis or trans, this negative charge participating in the resonance, this is called cis enol. Okay, cis enol is participating with the alpha beta unsaturated and get a cis product only. Then this carbon attacks this alpha beta unsaturated tertiary butyl. So this is the final product. Here we have next one. Here we have, it is enamine. This is alpha beta unsaturated nitro group. Then ETOH and HCl is there. So this is acidic condition in the protic solvent, and this is ether. Now this lone pair on the nitrogen group is participating in the resonance, and this double bond is migrated on this one, and this pi bond is participating in the resonance with the nitro group. Okay, and after that the HCl is a cleavaging of this one and get double bond. So this is a final product. Then it is this is alpha beta carbonyl group, and this is enamine. So this lone pair is participating in the conjugation, and this pi bond attacks this pi bond. This is participating in the resonance. and we will get this type of structure. Now loss of lone pair and get a positive charge and get double bond O and amine. So this is a final product. It is acidic this is heat means the loss of one hydrogen, and it is participating in the conjugation and get this negative charge is attacking on the iminium ion. Now we have 1 2 3 4 5 and 6, so it is 6-member ring, right? So like this, and this is 1 2 3 and 1 2 3. So this is the product, right? And here we have double bond O. Okay, next one. Here the titanium tetrachloride, alpha beta unsaturated carbonyl group, and this is so trimethyl silyl enol it is, and it is the trans is favored generally TMS, then it is also trans. And first one, the titanium is reacted with the silyl and get a transmetallation first. This is occurred first, transmetallation, because the reactivity will be enhanced. Then now this will participate in the Michael addition reaction, right? This negative charge is reverse conjugation and get a new CC bond formation. Now this will be exchanging of this one when we are redrawing. Okay, so now this negative charge is reverse conjugation is participating, and now this pi bond is attacking on the double bond. So for example, this double bond O here, then this one. So we have the 6-member, right, and alcohol. And after that, the even CB mechanism, because this hydrogen is participating in the conjugation because of titanium chloride. Next, this negative charge is reverse conjugation, and this pi bond is migrated like this, and actually it is a hydroxide is not best leaving group, but even though it eliminates forcefully, then alpha beta unsaturated carbonyl group is created, right? So this is the final product. Okay, now the next question is, it is also TMS chloride, so it is a trimethyl silyl enol, and here we have also trimethyl silyl enol, but this is only oxide, and this is alpha beta unsaturated, so this is OMe. Now HgI2 is a Lewis acid. When it is participating in the chelation between this O and O, then that chelation can change the stereochemistry. For example, this is below of the patch. Okay, so it is a bulky group. Then this trimethyl silyl enol is participating on the above the side, but when this chelation with the Hg, then the stereochemistry will be reversed. So that's why we are using this HgI2 in this particular case. So this is I am writing R simply. Then this attacking below of the plane on this alpha beta unsaturated, and after that finally we will get this product 1. So this is 1 2 3, this is 1 2 3 OME, right? At the second position we have double bond. So this is a final product. Alpha beta unsaturated, and this is a tertiary amine. Tertiary amine is a base. The base can abstract this hydrogen. Okay, so after that, so what happened, this negative charge is participating in the conjugation. So this is totally, I'm writing R simply. So R double bond O and tin ditriflate. Actually we have one CH3 group, right? So this is bulky group, then the CH3 group is cis to this one because it is a softer nucleophile, right? So it enhances the increasing of the reaction only, right? Then the final product, and here we are using, and this is the tin enol is a Z only, then the final product is syn. Okay, the Z gives syn only. C double bond O, and here this is CH3 group. Here we are observing carefully, and this pH3 is also above the plane. This is pH. Now it is alpha beta unsaturated is cleaved. This is beta, this is alpha, this is beta, and this is alpha, and next double bond O and CH3. So this is the final product. Now here the K2CO3 is the base in the ethanol, and here we have, this is carbonyl group, it is activated, then the most active hydrogen here, this one only. So K2CO2 base abstract this hydrogen, and here there is no other molecule, and only the alpha beta unsaturated is within this molecule, then it is an intra-Michael addition we are called. So this negative charge attacking this alpha beta unsaturated, right, and in the participating in the conjugation, and after that finally we will get a 5-member ring, right? This is 1 2 3 4 and 5. Okay, so I'm writing like this. So it is CO2 ET, but here the stereochemistry is what happened. Okay, generally when, for example, this bond is, for example, this bond is above, then the hydrogens are below, this hydrogen is below. Okay, now this above of the carbon attacks on the above side only, hence we will get below of the plane of hydrogens. Okay, so this is a stereochemistry. Now here we have, this is CO2 Me, and this is amide group, alpha beta unsaturated. So this is also intramolecular Michael addition reaction only. Then this is LDA THF, which is kinetically controlled, and LiBH4, it reduces esters, right? It reduces esters, not amides. So this is ester, but not now. When first of all we are using LDA. So LDA means this is most active hydrogen and participating in the conjugation. So what happened? Okay, now what happened? So actually it is now when this negative charge is reverse then this pi bond is attaching or attacking on this alpha beta unsaturated. So what happened? The 5-member ring is formed. 5-member ring means it is a off envelope cover. So like that model, then we can write before that. Okay, so this is, now this group is above the plane for the stable of this compound. Actually we have like this. Okay, so now this double bond is below of the plane. This is CH3 group, C double bond O, NR2. NR2 means we can write, we can use Winrib amide also. Now This double bond is also same plane. Now this is O minus and OM. Where it is a lithium, then lithium plus. So this lithium plus, this O minus, when it participates in the reverse conjugation, this pi bond attacking on this one, and this pi bond is participating with the carbonyl group in the conjugation. So what happened? So here we are getting 5-member ring only, right? So this is one. So here we have the 5-member ring. This is CH3. This is above the plane, Me. This is below and this is also below, right? So this is the stereochemistry. Now this is ester, C double bond O, OMe, right? And after that, this is CH3, C double bond O, N R2. After that, when we are using LiBH4, so this LiBH4 reduce the ester only and get alcohol. So this lone pair of oxygen is attacking on this carbonyl group, and when it is the reverse, this amine group is eliminated, and we will get 1 2 3 4 5 6. So 6-member ring is formed. So this is the 5-member ring and this is 6-member ring, right? And this one is above the plane and these two are below the plane. Then these 2 hydrogens are above the plane. So this is a final product. Now here we have potassium tertiary butoxide and the tertiary butanol at 50 degrees Celsius. Then it is thermally controlled. Then it attacks the more inert side only. Here actually the R means C double bond O, OM. It is activated, then get negative charge on this one, and it participate in the alpha beta unsaturated addition reaction. So what happened, right? This is C double bond O, this is R group, 1 2 3, 1 2 3, right? CH3. Okay, when we are redraw this one. This is K plus, this is, now actually it is aldol reaction, aldol condensation. Then this O minus participating in the reverse conjugation. This pi bond is attacks on the carbonyl group. Then the final product is R, and this is 6-member ring, C double bond O, and this OH. And after that, this is E1CB mechanism. Then after that, alpha beta unsaturated is formed, right? So this is a final product. Here we have alpha beta unsaturated carbonyl group, and this is enamine, CPH and reflex. So what happened? So this lone pair is participating in the conjugation. This pi bond attacks on this pi bond. It participate in the conjugation. So what happened? Right, this is 1 2 3, this is 1 2 3, negative charge and Me. Okay, so after that, here ACOH, NaO, AC, and actually it is a buffer solution and water. So water, cleavage of this double bond and get a double bond O. And when we are redrawing this one, then we will get like this structure. Okay, this negative charge come back and attacks. This is aldol condensation as above. The final product is, this is 1 2 3 4 and 5 6. So 6 member ring is formed, alpha beta unsaturated carbon. This is beta, alpha beta unsaturated. So this is a final product. And here last one, alpha beta unsaturated ester, and this is R, and this is DAPCO. DAPCO means this one. So it is a tricyclic ring, it is DAPCO, and these lone pairs on the nitrogen, actually this is nucleophile and attacks on the alpha beta unsaturated, because there is no base and there is no alpha hydrogen, whether it is or whatever we know, whatever we don't know, then okay, totally I'm writing this is R, so this is R. Okay, now this R C double bond O participating now in the reverse conjugation, it attacks on this carbonyl group. So after that, this hydrogen is forcefully participating in this one in the conjugation. OH, O minus, OET, this is argon. When it participates in the reverse conjugation, and this R group will be eliminated. Finally, we will get this type of product. Okay, so this is totally Michael addition reaction. Thank you.